All right, today we're going to be doing solving systems of linear equations by elimination. All right, our state standards are provided here. And to be successful, you need to be able to add and subtract linear equations. You need to be able to solve a system of linear equations by elimination. You need to be able to explain why the elimination method produces a valid solution. And you need to be able to solve real-life problems using elimination. All right, so what is elimination? Elimination is the process of removing something. When you solve a system of linear equations by elimination, you add or subtract equations to remove one of the variables. Why? If you remove one of the variables, then you can solve for the other one. Hence, you can solve the system of equations. All right. Key idea, solving a system of linear equations by elimination. Here are 4 steps. You need to have these in your notes. This is what we're going to be using in order to solve using elimination. All right, equation 1, or example 1, solving a system by elimination. All right, so we have 2 equations here, 3x plus 2y equals 4, and 3x minus 2y equals negative 4. All right, so my x's have the same coefficient, and my y's have opposite coefficients. So I can add or subtract here. It doesn't matter. So this equation is going to be fairly simple to solve for either one of these. All right, so remember step 1 said you need to add or subtract the 2 equations to eliminate one of the variables. Sometimes you have to multiply, but in this case, it's already set up and ready to go. So most of you guys like to add, or at least I like to add. I shouldn't say you guys. I like to add. So I'm going to add these 2 equations together. So 3x plus 3x is 6x. 2y minus 2y cancels, so that's eliminated automatically. That's why I said this equation is very nice because it's set up, ready to go. And 4 plus negative 4 equals 0. So divide both sides by 6. 0 divided by anything is 0. So very quickly we found our first variable, x equals 0. Now we have to plug it back in to find y. You can choose either equation. Let's just make things easy. Go with the first equation. So 3 times 0 plus 2y equals 4. This will cancel. 2y equals 4. Divide by 2. Y equals 2. So our solution is 0, 2. Again, you should plug it in and check it. So this is my x, this is my y. So 0 times 3 would be 0. 2 times 2 is 4. 4 equals 4, so that works for the first one. And then 3 times 0 is 0 again. Negative 2 times 2 is negative 4. Negative 4 equals negative 4. So very quickly, you can plug that in and see that it does work. So 0, 2 is the solution to each equation, and it is the solution to the system of equations. If you graph those lines, you would find that this is the point of intersection as well. All right, example 2, solve the system by elimination. All right, our first equation, negative 10x plus 3y equals 1. Our second equation, negative 5x minus 6y equals 23. So if we add these equations together, nothing eliminates. If we subtract these equations, nothing eliminates. So back to the notes from the first page. If you need to, you have to multiply one equation by something first. All right, so if I look, 3 goes into 6 twice, and 5 goes into 10 twice. So this will be very easy. I'm going to try to eliminate my x first. So I'm going to multiply the first equation. Well, maybe, let's see. I'm going to multiply the first equation by 2. All right, if I multiply the first equation by 2, I'm going to get 6y, and 6 plus negative 6 will eliminate my y's. So I'm not going to worry about what the x's are right now. I'm just going to focus on eliminating the y's. So 2 times negative 10, you have to multiply by the entire equation. So negative 20x, 2 times 3y is 6y, and you have to multiply what's on the right as well. So 2 times 1 is 2. All right, so far I have not changed my second equation, so I'm simply going to bring it down. All right, now we're working with elimination. So now I can add these two equations together. Okay, if I add these two equations together, negative 20 plus negative 5 is negative 25x. 6y minus 6y cancel, and 2 plus 23 is 25. Divide. And I'm going to get x equals negative 1. All right? Now, plug that back into one of the equations. It doesn't matter which one. So let's say negative 10 times negative 1 plus 3y. Does that, oh, I'm not trying to check it yet. Hold on. All right, I'm getting ahead of myself. So negative 10 times negative 1 is positive 10 plus 3y equals 1. Subtract 10. So 3y equals 1 minus 10, which is negative 9. Divide by 3. Y equals negative 3. All right, so that solved for my second variable. So my ordered pair is negative 1. X always goes first. Negative 3. And now you need to check it. All right, so just plug this in and check it. I'm just going to do a mental check real quick. Negative 10 times negative 1 is positive 10. 10 plus 3 times negative 3 would be negative 9. 10 minus 9 is 1, so it works for the first equation. Negative 5 times negative 1 is 5. 5 minus 6 times negative 3, that would be plus 18. So I'm going to have 5 plus 18 is 23, so that works for the second one as well. So we have checked both equations. All right, example 2b. All right, if we look, we have 2x plus y equals negative 4, and we have x plus y equals 9. Since we have a y and a y, now if I add these, I get 2y. But what if I subtract my equations instead? So when I subtract, you have to subtract all the way across. So don't forget to distribute that negative all the way across. Sometimes it's easier just to say plus, put a minus here, put a minus here, and put a minus here. That way you know that it goes with each one of those terms. So 2x plus negative x, if I add those together now, I will eliminate my y's. So 2x minus x is 1x. Y plus negative y cancels. And negative 4 minus 9 would be negative 13. All right, so very quickly, because we multiplied the second equation by negative 1, that allowed us to find the value of x. So now I'm going to do 2 times x plus y equals negative 4. So I'm just plugging this value in my first equation here. All right, so that'd be negative 26 plus y equals negative 4. Add 26 to both sides. Y equals 6 minus 4 is 2, so that would be 22. So that would be my y value. So we have an x of negative 13 and a y of 22. Again, you need to plug that into both equations and check it. Since I kind of wrote on my equations, you need to plug that into your original equation. So I'm going to kind of undo some of this mess here where you can see the original equations. All right, so we're going to have, this is our check. So we're going to have 2 times negative 13 plus 22. Does it equal negative 4? So it's negative 26 plus 22. Negative 26 plus 22 is negative 4. That equals negative 4, so that one works. All right, and then negative 13 is my x, plus 22 is my y. Does that equal 9? Negative 13 plus 22 is 9. 9 equals 9. So you can see that this does work when you plug it in and check it.